Thanks everyone for joining today. Appreciate your time. So a little bit of background. This talk actually came up several years ago as several of us were studying for our CCIEs, and we were noticing all these commands in iOS that did kind of cool little things, and we just realized, wow, we hadn't been using them to all their abilities, and then it grew from there. So it's really almost could be considered some best practices, some hidden commands, that sort of thing as far as a talk goes. And so that's kind of what we're covering here. So we'll go ahead and dive right in. So the first item I had up here was loopbacks or loopback interfaces. Many of you may already be aware of what a loopback interface is. If not, it's a logical interface on the router which never goes down. So they're very handy because you can source information from them, and you have a predictable source IP, which makes filtering and so forth easier. And second, no matter what happens, that interface pretty much never goes down. So if I have a WAN connection, or a WAN router with several WAN connections, I would never want to monitor off of one WAN interface, because if that WAN interface went down, it would look like the whole site was down. So instead, we monitor off of a loopback. We also source things off of a loopback, things like logging information, TAC access, and MP, all sorts of different things. It's might be kind of basic for some of you, might not for others, but it's a really important best practice. It doesn't really cost you anything. However, it makes operations of the network a lot easier. As far as how to configure a loopback, it's as simple as you kind of see here. You just create the loopback. Typically, loopbacks have a /32 or host IP address. That's not a hard requirement, but that's pretty common. And then you might do things, as you can see, like I might stick my routing protocols, process ID to the loopback IP, because again, it's not going to go down. I might, source my TACAX information from it, but you can kind of get a feel for that. And we'll see loopbacks throughout the first probably 6 or 7 slides. This one is NTP, or Network Time Protocol. And this is so critical these days. It used to be NTP was convenient when you were doing certain kinds of troubleshooting. These days, we're in such a highly regulated, security-centric focus in our networks that NTP has gone from a really good idea to really a critical must-have, right? If there's any kind of a breach or an event or something like that, and then you have to have forensics done, if you didn't have things like NTP enabled on all your devices, it makes that job very difficult, if not impossible, to complete. So it's as simple as you probably think. It's just there to synchronize your time to a source of truth. That could be a public source of truth, like a clock out on the internet. MIT had a famous one for a lot of years, probably still does. Or it might be an NTP server that you have internal to your network. And they're not terribly expensive if you prefer an internal NTP. And usually what you'll do is do it in a hierarchical sense. So you'll have your source of truth, and you might have 2 devices or some regional devices that sync up to that. And then all your other devices will sync to either their regional devices or to both of your internal devices. However you want to set your hierarchy up, it's somewhat dependent on your specific network. And of course, the pop quiz question is, what interface would you be sourcing NTP from? You'd be sourcing it from the loopback interface, because again, that never goes down, right? Also, NTP can be authenticated if you have that desire. I typically see people want to authenticate NTP if they're using it, or if they're using a source of truth out on the internet, and they may not require to authenticate it if it's something that's inside their own private data center. As far as configuration, you can see how simple it is. Really, we just set up our servers, our source IPs, and then some nice commands, show NTP status and show NTP associations, to kind of ensure that we're getting the timestamps we want. Next one's Snmp, or Simple Network Management Protocol. If you have a network device, you probably already use Snmp. It's about the oldest management protocol used out there these days from an IP perspective. It's been around for decades. And a couple of things to keep in mind with Snmp. Number one, do you actually need Snmp read-write? And if you do not actually need read-write, if you do not need to do a write through Snmp, please do not enable the read-write string. Just leave it unenabled, right? We used to use a lot of tools back in the early 2000s, late 90s, where they could only affect a change if they had SNMP read-write. That requirement, in my estimation, has gone down quite a bit. A lot of tools don't use that anymore. They may affect a change through perhaps a RESTful API or direct SSH or something along those lines. So if you don't need the SNMP read-write string, please do not enable it. Second best practice, always consider using SNMP V3. It's just far more secure. It allows us to do usernames and passwords. It allows us to encrypt those passwords. So SNMP V3, there were some implementation issues with SNMP V3 for a while. I think all those have mostly been worked through. So if you're going to use SNMP, which almost everyone does, please consider SNMP V3. And no matter what version of SNMP you use, you must secure it with an ACL. And we'll have a slide specific on best practices around ACLs. But, you don't have a network usually where every single host in the network needs SNMP, even read-only to a device. Usually you have a small group of management workstations that need SNMP, right? So create an ACL that only allows those hosts that actually need SNMP, right? SNMP is very powerful as a tool, but it can also be very powerful in the hands of someone who doesn't have your best interest at heart, right? And again, pop quiz, what interface would we source SNMP from? And the answer, again, is going to be the loopback. We would always source it from the loopback. From a configuration standpoint, again, you could see here's a basic, there's a lot of options on SNMP. You can kind of see here where I'm sourcing my traps off of loopback 0. I have ACLs. First ACL is called RO-SNMP, second ACL is RW-SNMP, meaning if it's a read-only server or a read-write server. Some nice fields would be things like SNMP location. So you can put the location of that network device you're monitoring in there, who to contact, and whatever traps you want to enable. And then our ACLs down below, right? So logging goes hand in hand actually with NTP. So logging is another one just like NTP that's become so critical over time. If we're not logging these days, then we have a hard time recreating the forensics around any event. It doesn't always have to be a security event. It could just as easily be a network outage. However, top of mind for a lot of people these days would be things like security events and security forensics. And so logging and NTP timestamps kind of go hand in hand. Few things to keep in mind though when it comes to syslog. The first one is if you're going to grab logs, you also have to have someone who will review them, right? So as an example, in our managed services practice, the NOC comes in and the morning shift always begins the day reviewing the logs from the previous night. And it could be something looking for simple like a fan failure, or it could be something as severe as, well, this is odd, the IPS fired on this kind of attack, right? But if you're not looking at those logs, you're always going to be reactive and never proactive. So that's kind of step 0 is be sure you have a process in place to review those logs. And there's tools out there that could help with it as well. Be aware that logs can eat bandwidth, and depending on how long you store them, they could also eat disk space, right? So you need to probably consider some kind of centralized logging service. I wouldn't log all over the place. I would keep it central. There's tools that are very good at analyzing centralized logs. And even if you didn't use tools, if you were just going to use grepping through a file on a Linux box or something, you still want to do that on one Linux box, not 20. And then, work with your company to determine what your policy would be for how long to retain logs. And this can sometimes be well-defined. If you're in a PCI situation or a HIPAA situation or something like that, it may be well-defined, or it may not be well-defined, and you just need to come up with a standard policy. So you want to keep an idea of how long do I retain those logs? And again, what are we going to source those logs from? We're always going to source them from loopback 0. There's a lot of different ways to configure logging. This is really just to give you an idea of how simple it can be. It's different on different platforms. It looks different on an ASA, for example, versus a router versus a switch. But by and large, you're going to turn logging on to a particular host. You're going to set to a particular logging level, in this case, warnings, and source interface. And if you're doing traps, what are you going to trap on? So DNS, this is one I sometimes get some pushback on, but I try to explain. I'm not asking people to run DNS on their routers or switches. I really recommend, though, that they put their routers and switches into their DNS, right? And of course, what interface gets added as the IP for resolving? The loopback interface, if the device supports a loopback. Now, a layer 2 switch does not, so in that case, a dedicated management VLAN. Or if you have a dedicated management interface, like on a Nexus switch, for example, you could also tie it to that, right? But you want some kind of DNS usually on these. Why do you want that? Well, when someone sends you things like a trace route, it's much easier for you to tell where things went and died if you have some kind of DNS resolution. So I just find that in troubleshooting, having my devices in DNS can speed troubleshooting, particularly when I'm working in a situation where not everyone is just on the network team. I may be working with desk side services, I may be working with server folks, and some of them may already have some good IT troubleshooting skills. This helps them understand where things might be getting holed up or black holed or dropped or something like that. As far as enabling DNS on the router or switch, it's actually really easy, right? You put in a domain name. You're going to do that anyway when you get ready to configure SSH. And then domain lookup and name server, that's if you want the router to also be able to resolve DNS. If you prefer not to have your router resolve DNS, you can just do a no IP domain lookup. So a lot of times what I find is folks start with the no IP domain lookup. They don't want that long timeout, which we'll talk about in a few slides, when they put in the wrong name for something, and then they re-enable it because they get to troubleshooting and then they forget to disable it. So I tend to find these days it's easier just to go ahead and have it, and then we'll deal with how we speed up the failure time if you type in the wrong DNS name on something. SSH, this one's pretty simple, enable it, right? So there's really no reason to not run SSH on everything, and more importantly, only SSH on everything. So you'll see down at the very bottom here on my line VTY 0 to 4, I have transport input SSH. That means that Telnet is actually disabled. I do still run into places that do SSH and Telnet. Maybe they think that they don't want to buy an SSH client. You can get a free one through PuTTY, for example. So there's a lot of options. This is, again, kind of the minimal you need to do. You need a domain name. You need to generate a key. A lot of times these days, we are generating 2048-bit keys, not 1024s. And you need to set a timeout and a number of retries. The 120 and 3 are defaulted. I put them in there just for completeness. And then you need to take your VTY lines and enable it for SSH. Access control lists, or ACLs. So when I started my career as a network engineer over 20 years ago, ACLs were really a security mechanism only, right? We used ACLs to, say, block access to a particular server or to, allow access into something. These days, however, ACLs are really used for enumerating traffic. And when I say ACLs, I really mean any kind of access defining technology. So it would also be true for prefix lists, for example, which I use a lot these days. And the important thing about these is they are used really more for enumerating traffic more than they are for controlling access any longer. They can still absolutely be used for controlling access, but they just do so much more than that, right? If I set up QoS, it uses ACLs. If I'm doing redistribution, they use ACLs. I'm setting up PBR or route filters. All of those things use ACLs. So they're pretty important to the general config and health of our router. And so I have a few best practices around that. I recommend you only use named ACLs. That way it's much easier to know what that ACL is for. And then I also recommend that you remark them, every ACL, and I say remark them in a reasonable manner. Reasonable can be a little bit, wishy-washy. In general, I say, hey, for every major portion of an ACL, set up a remark for that major portion. So here's an example. Standard ACL, I've named it route underscore filter, underscores, dashes, either way works. And you can see I'm not going to put a remark on every single IP address. I just say, hey, permit only these 1918 RFC 1918 addresses, right? The 10/8, 172.16/12, and the 192.168/16. And then over on an extended ACL, we use these a lot for QoS, so I used QoS as an example. I might put in a remark per application, right? Maybe that's too granular, but you need some level of remarking. And again, the name of the ACL should also reflect where or how that ACL is applied. So you can very easily tell on the left, this ACL is applied for filtering routes. Now, these days, this is actually a little bit old and I should update this. I typically tie the routing process as if it's a route filter, right? So I might usually these days say, route filter for BGP. If I'm doing redistribution, I might say OSPF into BGP or something along those lines, right? I think it's pretty easy to get the feel for where I'm headed with this. Banners. Banners are another one from a security perspective. They're just a must-have these days. I have a few recommendations on banners. Number one, if you want all the details on the different types of banners, login, message of the day, exec, etc., you can go to the link that's in the slides here, which will be posted on our website afterwards. However, it doesn't really matter which one of these you use as long as you use at least one. I usually use exec most times. I see some people that use login and exec. However, you need to have at least some banner. And what should that banner say? That's a little bit tougher. There's a lot of good recommendations out on the internet. SANS Institute has some. Effectively, you need something that stipulates that, hey, this is a private device. You have no right to log in, unless it's been expressly granted or something like that. If you have a legal team at your company, it's a good idea to engage them and ask what their recommendation is. Some of my larger enterprise accounts, that's exactly where they get their banners, is from their legal counsel. A lot of smaller customers I work with, they may not, just have legal counsel, on call, or a law department or something like that. So they'll go to something like the SANS Institute and take a look at what's up there. So here you can see basically we just say, hey, this is a private network device, access to this device is not authorized. Everything is logged. You have no expectation of privacy, and legal action will be taken if you don't belong here, right? Things you never ever put into a banner. You never use the word welcome. You never use names or IP addresses. You never name departments. You never say, if you're not sure whether you should have access, please contact, helpdesk at xyzcorp.com or something like that. You never put that kind of identifiable information in there. Services. So services is very simple. Basically, it's just like with any other server. You want to disable everything that you don't need and enable everything that you do need. So effectively, depending on your iOS version, not all of these need to still be disabled or enabled. I keep them because I run across all sorts of different versions of iOS in my work as a network architect. And so even though I may not still need things like no service pad, for example, I still put it in there because it's not hurting anything to paste it in, even if it's already disabled these days, right? Similar to, I think, on some of the newer iOSs, TCP small servers and UDP small servers is already disabled for you, right? But these are all the things that I tend to disable. And then down below are all the things that I tend to enable, right? Password encryption, keep alive, and timestamps, right? So timestamps allows you to take that NTP information and timestamp it on to your debug and log messages, which again is just very critical to everything you're doing from a security and operations perspective. Let's talk a little bit about passwords and secrets. It's actually pretty easy. Never use passwords, always use secrets. So passwords are effectively unencrypted these days. There's hundreds of websites out there probably that can easily decode a standard password, and that's why we use secrets instead. When it comes to secrets, the biggest rule of thumb is we never ever want to use level 4 encryption for our secret. There was a flaw in the algorithm, in what they call the salting of the algorithm, which allowed it to be cracked quite quickly. So anything is better than 4 when it comes to secrets. So a 5, which is based off of the MD5 hash, is better than a 4, for example, right? If you're running anything recent in your iOS, you can probably use 8 or 9. 8 maps to a SHA-256, and 9 maps to script encryption. So either 8 or 9 will work very well for a good, strong, unbreakable or mostly unbreakable secret. Effectively, if you're using an 8 or a 9, there's nothing that can reasonably crack that quickly. And then, of course, don't use something easily guessable. This should be, probably is common knowledge these days to most IT professionals. I probably don't need to say this, but don't put in your company name or something silly like that, right? Come up with a secret that is A, properly encrypted, and B, properly complex. So I alluded to this when I talked about DNS. If anyone's ever done where you typo, maybe on an IP address where you're trying to SSH, I'm trying to SSH to 10.1.1.1, accidentally type 10.1.1.11, and you wait for that 90-second timeout, feels like it's 90 minutes. It's actually 90 seconds, but it's annoyingly long. Or I type ping www.cisco.com and I typo, instead of .com, I type .ocm or something, and I need to wait again that 90 seconds for DNS to fail. If you've ever wanted to shorten that wait time when you do something like that, you can use a command called TCP Synwait. You can see kind of down below, here's an example where I tweak it down from the default of 90 seconds to 6 seconds. It's just IP TCP Synwait time, 6 seconds, and effectively it will speed up those timeouts for you. VTY and console port health, right? So my first recommendation there is, do you really need 16 VTY ports? I'm not sure why Cisco went from just 0 to 4 to 0 to 15, but they did several years ago. And so I tend to counsel people that you probably don't need that many VTYs, right? 0 to 4 is probably sufficient. You probably don't have more than 5 people SSHing into a device at any given time. And so from that perspective, I typically recommend that you disable the 5 to 15. You can just set the timeout to 0 seconds, so effectively you can't log into it. Another thing I tend to recommend is the logging synchronous command. If you've ever been in a situation where you may be troubleshooting something, you may have a debug running or logging to the terminal running, and you're also trying to make a configuration change at the same point. Maybe you're trying to shut down a port or change an IP address on a port or something like that. And your terminal gets an output from whatever process is running, like a debug, and now you can't see where you were typing. Logging sync repaints the line that you were typing in, right? So I find this to be a very, very helpful command operationally. I tend to put this on all my VTY and console ports. Logging synchronous it's a great command. This is kind of similar to my recommendation for ACLs. It just goes a little bit further with it. And that is, anytime you have a chance to assign a name, a description, or a remark, you should. When I talk about network designs and architectures with different groups of people, I often talk about this concept of verbal significance, and these are all ways to implement verbal significance into whatever network device you're configuring. Now, when it comes to things like interfaces, critical interfaces, I definitely put descriptions on. If these are the interfaces that are going to my different ERP systems or something, I probably put the system names on those interfaces. And likewise, if I'm configuring my router for a WAN circuit, I almost always put, the circuit ID and the 1-800 number that I call to service that circuit ID, so that anyone who gets a message about that circuit being down has an easy way of figuring out how to troubleshoot that. However, I wouldn't go so far down the path on interfaces that I would name, say, out in an IDF, the individual switch port interfaces that are going to different cubicles. The reason I typically don't do that, and I've seen it done several times, is I just find it's not a very scalable solution. People start repatching things, they start moving things around, and you're not probably in the business of updating interface descriptions every single day, and no one thinks to tell you, oh yeah, we went in there and repatched this to this because we thought maybe the port was bad or something. And they may not ever tell you that they did that. And so I don't go down that far. ACLs we've already covered. Route maps are very similar. Again, when I name the route map, just like an ACL, I give it a name that's meaningful. OSPF into BGP. static into EIGRP, something along those lines. On route maps, I also start the steps at 5 and do increments of 5 so that I can insert, if I ever have to, below or above a step. I would never do, 1, 2, and 3 for my route map steps. I would always put a gap of 5 in there so that I have some ability to influence it, because remember that route maps are executed sequentially in a stepped fashion. So the next one is Graceful Restart. This is really about routing protocols, and there's really two main types of routing outages from a very high level perspective. There's routing outages where the routing path is good, right? From A to B is fine. However, my route process maybe has failed. So in a chassis-based switch, this might happen when you fail over supervisors and the route process has to move to the other supervisor. Or in a switch stack, similar, right? When it goes from the primary member in the switch stack to the secondary member in the switch stack, again, the route process may need to reestablish. Similar with firewalls, different things like that. In that case, my forwarding path is good. I didn't have an interruption on my forwarding path. It's not like a link failed. It's a process that failed. Graceful Restart allows you to route through an outage or an interruption in service. And you can only route through an outage when the outage is on the process, not on the physical link or something along those lines. And so Graceful Restart is a great tool. It's supported on many different vendors. Pretty much everything Cisco supports Graceful Restart these days. And you need to be aware that things need to be Graceful Restart capable, and they need to be Graceful Restart aware so that they know how to deal with that, right? And the idea of a Graceful Restart is that if the other device is aware, if I'm capable and the other device is aware, even though the routing process maybe is in a coming back up state, maybe it's in a OSPF, it's in an X start state or something like that, I'm aware though that you're doing a Graceful Restart, then I'm going to keep forwarding your traffic, no interruption. It supports the protocols OSPF, ISIS, EIGRP, BGP, and LDP. A few caveats, and they're small ones. During the route process failover, of course, you can't learn new routes, right? It just keeps forwarding along whatever paths pre-existed until the new adjacencies are formed. This is usually a sub-second to a few second outage, so this is not a big deal, but if you use a tool like an IXI or a Spirent, you can definitely see this because you can inject information faster than the Graceful Restart might catch up. So just be aware of that. The next one is BFD, which stands for Bi-Forwarding Detection, I believe. And this is the other solution, which is I can't route through an outage because I had a link failure. So instead, I need a route around an outage. And normally if that happens, so we take a look at this drawing down here, and this happens all the time in WANs these days. When we used to have TDM circuits, it didn't, but now that everything's an Ethernet handoff, it can easily be that on one side I may have a hard down when that on the right you can kind of see where that link has kind of gone down, but the router on the left, he has no idea. He didn't lose, this is an optical connection, he didn't lose his light, for example, right? He's still got a working connection to that switch in the middle. And so normally, so Graceful Restart can't help you here because I don't have a route process fail. Instead, what I would normally do is I would fall back on the dead timer of the routing protocol. However, dead timers are notoriously long, and in this case, we should know just expire the dead timer, ideally. And that's exactly what BFD does. BFD, it doesn't rely on the protocol, but it informs the protocol of these sorts of things. So BFD, you could almost think of it as a very fast and aggressive hello timer in a sense. And so it's just constantly pinging back and forth. And when it misses a certain number of hellos, instead of starting some process, it immediately expires the dead timer for you in your protocol that's being informed. And so if I have a secondary path, I immediately start taking it. So this is not about routing through an outage. BFD is about routing around an outage. So if I have a secondary path, I immediately fail my first path. And when I say immediate, we're usually talking sub-second here for BFD. A couple of things you need to be aware of with BFD is you need to ensure that your ISP, when it comes to running it on a WAN router, you need to make sure that your ISP supports it. Many ISPs do, but not every ISP does. You want to be sure that that works. If you're looking, by the way, into SD-WAN, if you've seen my previous SD-WAN talks, Cisco SD-WAN solution uses a BFD-like mechanism for doing this exact same thing on their edge routers in the SD-WAN solution. So this is a very well-known technology. It's, again, multi-vendor, well deployed. You do need to make sure that your ISP is capable of supporting it if you're going to run it on the WAN edge. So the next one would be on the ASA, actually. There's a neat command called the TCP Ping Command. It came in, I believe, back in 8.4. And this is kind of nice if you ever just wanted to find out if not just a host is up, but if it happens to be listening on a service, right? So if someone opens up a ticket to you and says, hey, can you please fix the firewall? No one can get to my website. And typically in the past, what we would do is we would ping the website, and if it responded, we assumed, oh, okay, there must be something wrong. I check my NAT, so I'll check my access lists. But what was difficult for us sometimes was to determine, was the web service actually even listening, right? Was the web server even enabled, for example? And so you can just use on the ASA the command ping TCP destination and then the port, right? And it'll actually send over some SYN packets to see if it gets a SYN ACK back on that port. You can use this, by the way, in conjunction with the capture command. So this came directly from TAC talk that I attended at Cisco Live this year, and they mentioned this, that TAC uses this a lot, right? They will do a TCP ping and then use capture, and then they can pass the capture along to the server team and say, hey, yes, I can ping your box, but no, I cannot seem to get a SYN ACK back on port 80. Please check your web service, for example. We used this command recently at a client of mine on a big ERP project where they were very resource constrained on the server side, so we were running into this a lot, where they would spin up a server, they would ping the server, they would assume that meant all the services started, and then they would turn it over to us, and we had a firewall sitting in the middle, so there would be a lot of firewall tickets. So quickly we put this into part of our process to do a TCP ping. About maybe a third of the time, we'd come back and say, oh, it looks like you're not listening on that port. So, and again, we'll post the slides up on our website later. Stuart will take care of that for us. Some links at the end. This is just if you want to read a little bit more about Graceful Restart, if you want to read a little bit more about BFD. We didn't cover unicast RPF or reverse path forward today, but that's another security technology. That one's a little more intrusive, so be sure you read about unicast RPF before you implement it. That's why I didn't put in a specific slide for just turning it on. It can drop traffic in certain environments, so you do need to be a little bit careful with it. And that's really it for the slide. Thank you, everyone. Appreciate your time.